We present to you Newton's first law of motion with orbital motion. Enjoy! Thanks to Sir Isaac Newton, we now have the laws of motion to study. An object in motion stays in motion, and an object in rest stays in rest, unless acted upon by an unbalanced force. This is known as Newton's first law. Before we can analyze Newton's first law in relation to orbital motion, we first need to find a way to get up there. And a rocket should do just the trick. Prior to the liftoff of a rocket, the rocket is at rest and its velocity is 0. When the engine is ignited, the thrust of the engine creates an additional force opposed to the weight. That force that the thrust creates is an example of the force that Newton's first law is talking about. The thrust is the unbalanced force that causes the rocket to overcome inertia. When the thrust is greater than the weight, there is a net external force equal to the thrust minus the weight, and the rocket begins to rise. Orbital motion. Orbital motion can be defined as the motion of an object around a fixed point, such as the Earth around the Sun and the Moon around the Earth. Because planets move in an ellipse, this law states that there must be a force acting upon a planet or the satellite, otherwise they would continue in their path along a straight line.
Orbits are the result of a perfect balance between the forward motion of a body in space, such as a planet or moon, and the pull of gravity on it from another body in space, such as a large planet or star. There is a continuous tug-of-war between the object wanting to go forward and away, and the other body in space that pulls it in with its gravity. In order to create an orbit, the forces of inertia and gravity have to be perfectly balanced. If the forward movement of one object is too strong, the object will speed past the other and not enter orbit. If inertia is much weaker than the pull of gravity, the objects will crash into each other. Inertia is the tendency of an object to resist change in motion. Inertia causes the Earth to not fall into the Sun. Inertia and gravity combine to keep Earth in orbit. An object at rest stays at rest, and an object in motion stays in motion with the same speed in the same direction unless acted upon by an unbalanced force. Without forces acting on Earth stays in motion with the same speed and in the same direction, which is inertia. Though, the gravitational pull of the Sun pulls Earth towards it, but inertia makes Earth move forward. Satellite orbits. There are two types of satellites: artificial, like the GPS, and natural, like the Moon. Inertia plays a large role in keeping the satellites in orbit. Without inertia, the satellites will crash into Earth or move away from Earth. Here are some types of orbits for satellites. Low Earth orbits. This orbit is far enough so that an object will stay in orbit and not fall back to the Earth from drag. Over time, objects in this orbit will slow down. This leads to the object to fall back to Earth. This orbit does not have a long dwell time on areas. Highly elliptical orbits. It has a more elliptical structure. This orbit gives more dwell time on one area of Earth. If the orbit is very elliptical, the object will spend most of its time near the furthest point in its orbit, where it moves very slowly. Geosynchronous orbit. This orbit keeps an object at the same area on Earth since it travels the same speed as Earth. It has to be about 22,000 miles away from Earth in order to counteract the pull of gravity. Orbital decay is a process where two orbiting bodies gradually decrease their distance over various orbital periods. Some orbiting bodies are a star and its planet, or planet and its satellite. There are three different known ways orbital decay happens. When an object is in low Earth orbit, it increases orbital speed due to Earth's gravitational pull. Since the pull of gravity is stronger than the forward motion of inertia, the object will crash into Earth. When the Moon orbits Earth, it creates a tidal bulge. The bulges slow down the rotation of Earth, which means energy is lost by Earth. This energy is then transferred to the Moon. The Moon starts to speed up. The faster something orbits, the further the distance is become. The forward motion of the Moon is becoming stronger than the gravitational force of Earth.
This has been Newton's first law in orbital motion. Thanks for watching.
created using Powtoon.